Hello, welcome to the Desert Blockchain Monthly Meetup. It is 7 p.m. Arizona time on Wednesday, September the 28th, 2016. My name is Jake Carpenter, and we are Gangplank Chandler. And tonight we're going to be talking about a variety of topics: blockchain, distributed networks, decentralized networks, possibly prediction markets, the upcoming decentralized web games, and basically whatever folks are interested in talking about tonight. So there might be some folks joining us virtually, and if you're interested, you can go to the meetup page at meetup, and it's Desert Blockchain. So check it out and feel free to join us if you happen to be tuning into this. So we usually just kind of go around the room and introduce ourselves and talk about what you're interested in finding out about tonight, what areas you'd like to cover, and so forth. So, Bob, you want to start it off?
I'm Bob Andreessen. I work for CA Technologies. I do work on mainframes occasionally and other platforms like Linux. I'm trying to get background in blockchain. I'm seeing IBM is pushing blockchain quite a bit recently, so I think that's going to be something that we're going to have to deal with. Other than that, I'm just trying to learn.
Right. And is there anything in particular you'd like to cover tonight?
Definitely the decentralized web games. I want to find out what I should sign up for and what the structure of that is.
Okay, cool. Hui?
Hey everyone, my name is Hui, and I actually just recently moved here from DC. And
awesome.
Yeah, so what I'm doing is I have a startup that is a financial technology fintech startup that we can make payments, a payment system that also uses social networking as well. So I'm hoping that I can learn blockchain, and I've heard about it. I know the general idea of it, but not really the technical details. So I'm looking to learn about that so that I can, implement that with to reduce financial fraud, to prevent that, as well as, user authenticity.
Okay. Cool. So there's a little bit of identity built into it as well?
Yeah.
Okay.
Yeah.
Cool. Are you familiar with some of the blockchain-oriented startups that are in the realm of social networks and payments and stuff like that?
So I haven't really seen many other companies, since blockchain is really new. It's relatively new. I've seen stuff on Bitcoin, cryptocurrency startups that utilizes blockchain, but that's
okay.
I mean, at least that's what I'm aware of. So
well, maybe we could take a look at a few of those tonight.
Yeah,
it might be of interest to you. So cool.
That'd be cool.
All right, Glenn.
Hi everyone, I'm Glenn. I'm primarily interested in figuring out how to use blockchain in a variety of industries. My background is pretty much in startups. I've been doing startups since the good old .com days. And as we were discussing at the IoT meetup on last Saturday, the blockchain technology feels so much like the web, HTML programming, that type of stuff, way back in 95, 96. And when you start seeing the power of the distributed ledgers and the cryptography and all that, it just lends itself so well to so many different things, like the area that you talked about, fintech, obviously. So really, I'm here to soak in some information from you guys, get a different perspective on how blockchain is used, get an idea maybe about the difficulty of implementing or designing, custom blockchains. I know there's been a lot of stuff going on lately. Deloitte, just created an editable blockchain. And IBM mentioned how that they project 15% of banks are going to be using blockchain in 2017. So when the herd's moving this fast, you got to get up and, you take notice. The smart ones take notice, and hopefully that I can learn from you guys and share some stuff, and give back to the community.
Cool. Very cool. Well, I'll just kind of do a brief introduction of myself. I've been in the communications realm for like 20 years now, and very much in the telephony realm. And there's a big need in the telephony realm for identity and for taking the old telephony and moving it into the contemporary. So I've been very much involved over the last 15 years in initiatives at the industry level to do that. Advisory groups with the FCC, global initiatives and things like that. And about 2 years ago, I took a look at Ethereum and what they were doing. And I'd heard about, Bitcoin and all that stuff, but it wasn't very compelling. And then I started to look at what Ethereum was doing, and then I started to look at what the blockchain was and how the blockchain is sort of like the internet was to email back in the mid-90s. So the Bitcoin cryptocurrency stuff is big, but it's kind of like what email was back in the mid-90s, but the real underlying innovation was the internet. And that's kind of the way I see blockchain at this point. So I've been really looking at this, but my interest is in using the blockchain as like a global registry for naming, addressing, and numbering. So that's my interest.
Kind of like DNS type stuff?
Mm-hmm. Yeah. And there is a considerable amount of interest and energy that's going into identity management in this realm of blockchain. So there's something called Uport, which is built on the Ethereum platform, and it's trying to create something new in the realm of identity. In the middle of May this year, the UN had a conference where they're trying to launch an initiative to provide a realm of identity for the 1.5 billion people that don't even have a birth certificate. So there are many different dimensions, but there's a lot of interest in like the social networks and certainly the payments, and identity, I would say, is one of the key opportunity sets that if you can crack that, it opens up a whole bunch of stuff.
So that identity, does it kind of tie into social networks? Because that's pretty much like your own profile that you put your information.
Yep.
So, in terms of global identity, maybe if it got implemented and everyone had a profile on this network,
right,
then that might.
That's exactly right. And what if the identity was distributed? So there's not a central repository for identity. That's part of the value proposition. So
I think Deloitte, actually, bringing them up again, they've been working on an identity piece as well. The really scary part to all this, when you start hearing about IBM and Deloitte jumping in, is the fear of, or at least the anxiety that I get from it, is patents. Because this is only 6-7 years old, and with all these companies piling in, I'm concerned that all the patent stuff that's going on could have a chilling effect before folks like us get moving. So,
hey Leo.
hello.
Hey, welcome.
Sorry about that. I had to catch up with Eileen on a few things. So
That's cool.
No problem.
Did you see the pizza out there?
no,
It's quite
You want
good.
to go grab some pizza?
I do. I'm starving.
You didn't have anything to eat?
No.
So,
No, I got here to show you this. Can do a little reading up before tomorrow. If
Awesome.
anyone else is interested, I got more in the car.
oh, cool.
So I'll give you the details later.
Nice.
Let me not interrupt.
IBM
So-
is doing a lot of open source stuff with Spark, so it may not all be patented.
Mm-hmm.
So they're contributing to the open source community.
That's good to hear.
Yeah.
You know, because Microsoft was really scary for a while. It's interesting to see that.
Microsoft is
they're-
a different animal.
Well, Bank of America is filing patents on blockchain left and right.
Figures.
So it's
Everyone hates B of A.
yeah. So they're I mean, let's do a little screen sharing here, and I'll show some stuff that might be of interest. Let's see. Let's go right to this. So this is, let me show you some of the news areas that I follow. So this is Reddit, and if you're not familiar with Reddit yet, I would recommend you get familiar with Reddit. So here's a news item that ties into what we're talking about. Banks adopting blockchain dramatically faster than expected. IBM. Let's see. Ethereum just had a big conference. I think it was in Shanghai called DevCon.
Mm-hmm.
But let's look at some of the patent items. This
Well, there it is. Microsoft and Bank of America working together.
yep, on blockchain, they're filing patents like crazy. This might be of interest to you. This is a fintech crowd sale that I think they raised like $6 million in the first 24 hours. Wow. And there's another one that raised like, well, $5 million in 5 minutes for this blockchain investment. Let's take a look at what this was. So, 5 minutes. There's a lot of this, and it's really hard. First blood, or
Yeah, if they would have put AI in their pitch, it would have gotten funded in 2, right?
So,
Mm-hmm.
Elio, we're just talking about some of the developments.
Okay.
Bob's interested in the decentralized web games. Who is interested in social networks and financial transactions. Glenn is interested in just startups and entrepreneurial opportunities. And we were talking about some of the activity with like IBM and Microsoft. They're interested in the blockchain and also some of the patent issues around that. But a lot of these startups are going through something called crowd sales, which is a lot like an IPO, and they're raising crazy money really, really quick. But you can, there's something on here. This R3 for banking, you should definitely check that out because that's a consortium of like, I think 40 or 50 banks that have formed blockchain patents in 2016. Isn't patenting tech like blockchain contradictory? So there's all kinds of stuff on Reddit, and this is Reddit blockchain that's right on target with what we're talking about. But I'm going to open up another. this is another resource that I highly recommend. It's called Epicenter TV. And so it's epicenter.tv.
I will say they've had some really good talks on there.
Yeah,
Some of the ones that Jay sent me have been awesome.
yeah, they really have some awesome people on here. But let's see. This fellow, this Ryan X Charles, boy, you should definitely check that out because he is starting a social network to compete with Facebook. And
What's the name of that one? The network?
it's called Yours.
Oh, it's a different one then.
Yeah, I know. There's another one that just got funding, like did a crowd sale and raised several $1 million.
There've been a whole bunch, but anyway.
And by the way, you'll be able to see all this on the recording of tonight.
Okay.
So
I was gonna note everything. On my
yeah,
phone.
but he talks about Yours and particularly the micropayments. So they're talking about a way to pay people as they're posting social media.
This is building on Jaron Lanier's ideas from way back. Some stuff?
No,
Oh, so Jaron Lanier proposed a lot of that. He's actually, I think, the guy that coined the term VR, if I'm remembering right. So interesting guy. But he has a whole thing about imagine if you could have, instead of imagine if you could just send a tenth of a cent.
mm-hmm.
So if you liked a ton of stuff, like 100, 1,000 things a day, it would cost you a few bucks at most. But it would make the difference because now when you have a video that gets like 1 million likes, instead of maybe having enough likes to turn that into some ad revenue and make a tiny bit of money, you're now directly making dollars. So even if you're not getting 1 million likes, if you're getting, a few tens or hundreds of thousands of likes per video, you could do a few videos a year and actually make enough to live.
Wow.
So suddenly you can actually make a living by doing stuff that people like, and a like means something at that point when you attach monetary value.
Mm-hmm.
Versus right now, it's like it may loosely translate at some point, but a lot of times it doesn't. Google's making the lion's share off that. You're helping them.
Yes,
well,
exactly. That's exactly what he talks about in this episode.
So Jaron Lanier's been doing that kind of stuff for like a decade or two. So
I think the problem has been the micropayments. And
yeah, there hasn't been a framework to make that happen.
Exactly.
Credit cards used to have the 40% swipe fee. You can't do a micropayment if you're losing 40 cents to the banks every time.
Right.
It just doesn't work out. You got to be able to do a cent or less.
That's
True
exactly what he's
micropayments.
talking about here.
Yeah.
So, anyway, do you have any questions about that, or
So is this using cryptocurrency or whatever you were talking about?
they're actually using Bitcoin on this Yours platform because they're saying it's the largest. But in this session, they talk about the difference between using Bitcoin and Ethereum. Some people are using Ethereum because it's got these smart contracts. It's programmable, basically, contracts. And Ethereum's trying to build this like world computer. So that's those are some resources that I'd recommend you take a look at. This Steemit is also a social platform. So I haven't jumped into it, but Steemit is, I think, would be very much of interest to you.
Definitely.
There's another meetup group here in town called Blockchain Tech, and there's only 2 meetups that are associated with blockchain, but a month or 2 ago, they did a session on Steam and Steemit, how to program and how to set it up and stuff like that. So you might want to check that out.
So what is it called? Blockchain Tech?
Yeah, Blockchain Tech. So here, let me pull it up for you. So this is it. So they they meet over at a pizza shop, generally, but let's see. So they go over, they go into the kind of the hardcore technical stuff a little bit more than we do, but the Steam and Steemit, the blockchain social network that pays you to share content.
Wow, that's
That's right up your alley, right?
right up my alley.
Yeah.
I'm more geared towards the hospitality and restaurant industry for
Uh-huh.
now, because that's where I came from. But yeah, that was definitely the long-term goal, is to be able to monetize content from what you post.
Cool.
So
So, Brian Gemrick is very knowledgeable. And this fellow, Marcus Brown, was at the last day-long event here at Desert Blockchain. And he's familiar with Ethereum Classic, which is a fork of the Ethereum.
Yeah. I don't know if you want to get into all that, but yeah, I got
so
thoughts.
many forks.
Yeah.
Well, I mean, so that the gist of it is that's the problem, is there's this dream that you can do a totally trust-free, decentralized system, which doesn't make any sense. It's not logically, it just doesn't add up. It's nonsense. And every time we've had this, all of these systems, like Bitcoin right now, the 51% attack is a problem. There's no way around it. That's a known issue, is that if you own more than 51% or 51% or more of the network, you can rewrite history and make it say whatever you want. You can double spend, you can do all kinds of nasty, malicious stuff. And so they're like, but that'll never happen. And then not too long after, what was it, 2-3 years, MJ, when it really started gaining steam, they had one mining pool go over the 51% threshold for a few hours and then almost a day. So it happened early on. And at this point, China has so much more compute power that China has more than 51%. So if everyone in China decides to cooperate, with which a communist government is not an unlikely thing, they can do whatever they want. If you spend Bitcoin, they can unspend your Bitcoin. They can take it away from you. They can do whatever they want. So it's kind of centralized. China now runs Bitcoin for all intents and purposes. And some of the same stuff with like Ethereum. We've seen they had a bug, they had a recursive spin bug, where you can program this contract. So you could say, split and then allocate this, and then a fraction of this, and split and allocate this. And they were able to actually write a program that was siphoning millions of ether out of the main pool, out of the DAO, into a different account.
Yeah, they raised like $150 million worth of ether in less than 30 days.
Yeah,
And then somebody found a bug about 2 or 3 weeks later, and they siphoned off about 50 million.
Yeah. So the response was, we're going to fork this thing, because that wasn't the intent. We didn't mean for that to happen. And their whole thing was code is law. Like you write code, and that's you don't go to a judge. Whatever the code says is the truth. So we decided to fork, to undo that, to put the money back. But that totally contradicts code is law, and that totally contradicts having a centralized system. Because now the core group of maintainers, which is like 5 people or less, can now say, no, I know that the code said you got 50 million, but we're going to undo that, because that's not right. We don't believe it. So all of this, you always have to, the way we model trust, we still don't really understand it well. We don't really think about it in detailed academic terms. And a lot of the ideas that, we have a lot of really enthusiastic people getting into Bitcoin and blockchain and Ethereum and all this, but they don't really get it. And they haven't thought too deeply. They're just super excited. But when it really comes down to it, you always end up with some larger group of people gaining control and re-centralizing all these technologies. And so far, none of these has resisted centralization for more than a few years. And Ethereum went down real quick. That was what, less than a year out before it got centralized, or the fact that it was centralized got exposed.
Yeah.
So
there's a big tug of war between decentralization or distributed architecture and centralization. And governance is a huge factor in all of this. So, Rick, looks like you joined us. I'm going to click on you. You're muted. If you want to join the conversation, feel free to do so. Let me see if I can unmute you. Hi, Rick. Oh, well. You can shoot me an email, Rick, if you want to join the conversation, or give me a call.
They type
in, like there's like a chat thing on the side, right?
Oh yeah, that's right.
There you
go. So the chat.
I think it's the top icon thingy on the left.
The top one on the left.
Yeah.
So interesting technologies.
Next one down.
I've been coming to these events that Jay's been putting together. I like the fact that Jay's willing to not just look at Bitcoin, which is by far the most popular of the cryptocurrencies, but pretty much any and all decentralized technologies related to blockchain or not, or broader concepts. Because personally, I think blockchain is an interesting idea, but probably is not going to last too much longer, just because it's never actually panned out. The promises that it makes, no one has ever been able to deliver those for more than a few years. So the underlying technology upon which blockchain is based is a Merkle bag, and a blockchain is just a heavily constrained Merkle bag. It's kind of like every square is a rectangle, but a rectangle with constraints such that all the sides have to be the same. You can have lots of different types of rectangles, and a subset of those is squares. So the same thing with a blockchain and a Merkle bag. A Merkle bag is this really robust structure for representing information and tying it together cryptographically and synchronizing it and making sure everyone has exactly the same information really efficiently. And it's a great way of modeling human knowledge and how it changes over time. And that's what Git uses internally. If you look up some of the Git tutorials, you can see some of the properties of a Merkle bag. A blockchain is a heavily constrained one. It's not a Merkle tree, which is bringing a Merkle bag down to no branching. It's actually bringing it completely down to a straight line, where every block is referenced by the one after it, and there's only one line of blocks. And you're not allowed to branch at all, ever. The whole point of a blockchain is global consensus. And so the way they handle that in Bitcoin, and I don't know if anyone's found a way around this yet. We talked a little bit last time just on the phone, you and I, Jay. But right now, the only way that they do, they establish which is the true chain, which is the consensus, is longer chain, so proof of work. So they say, all right, if the network gets cut off and we got two, like this half of the world are doing their own thing and still spending money separately, when the networks merge back together, the system looks at both chains and says, uh-oh, we had a fork. Which one do we use? Which is the truth? Well, whichever one is longer, so whichever side did more work, we assume that was the bigger half of the network, and we throw away the smaller half. So that's actually really annoying. If the network globally gets partitioned and you go and you buy something and it comes back together, it might actually erase your transactions. So that's much more annoying if you're the one selling than the one buying, because it's theoretically possible for all those transactions to get erased and you have to reperform those.
Yeah.
So
this is still in its infancy. And I mean, the whole experimentation thing, this notion of immutability, which Haley was talking about, which turns out maybe it's not as immutable as everybody thought it would be, because you can get these groups together that can reverse transactions. So it's all on the table, but it might be useful to look at let me pull something up that might be of interest to you.
yeah. Now there are some really cool technologies. Jay showed one on there. There's IPFS, which doesn't do blockchain stuff. It does full-on Merkle bag. It's a global Merkle bag. It's interplanetary file system, or IP file system, as an interprotocol. And it is just basically a massive global shared file system that you can throw things into there, and then you can take the hash and say, oh, look, I want this thing. So I can put something in there. I can send you the hash some way or other. And then you're able to actually pull that item out based on its hash, which is really, really powerful for a number of reasons. And IPFS is by far the most popular. It's gaining the most support. It's growing the most rapidly. Very cool technology. Pretty well built, pretty well researched. The one issue I have with IPFS is, as opposed to previous efforts to do similar things like Freenet, it fails to take into account reader privacy. So it's very easy. Part of the way the system works is you have to be able to ask who has this data. And there's two things you need with data. You need to make sure it stays available, but you also need to make sure some data stays confidential. Because in order to make sure data stays available, there's always powerful groups. Look at banned books throughout history. There's always a group that wants to destroy certain data. And if they can find it, they'll destroy it one way or another. And so you need to both keep it available to the people that want it and value it, but also be able to hide that data from people who want to destroy it, because there always are. And so IPFS is brilliant at the first half of that. It's really, really good at making sure you can find the data, but it's not very good at making sure it hides it from other people. It's actually quite bad at that. So
This is the IPFS website, and I've actually got IPFS loaded on these Raspberry Pis, and I think IPFS is the most interesting platform or protocol to experiment with right now, above and beyond Ethereum and Bitcoin.
I mostly agree with the caveat. I think it is by far the one you should look at because it's the most popular. It's the best intersection of people actually trying to build stuff on it and decent technology. The most interesting platform has, and I still think remains to be off system, which no one knows about. But Freenet has been operational for 15 years and is, unlike Tor, is a completely separate parallel system that is built to, above all else, be almost impossible to de-anonymize people and destroy data and all that. And it's incredibly well built. The main drawback is, again, its adoption rate has been staggeringly low, and it's built in Java. And which is probably part of it. But they are working on some rebuilds of it in other languages, including one that still niche, but they're working on a Haskell build, which has some fascinating security implications.
So Alio is working on something called Nebula, which is another distributed network architecture that addresses many of these issues that we're talking about here. So, and maybe we can talk about that.
And I'll mention real briefly. So this is a lower layer protocol, IPFS, and Nebula is a layer above that. It's below the application layer, but between the application layer and IPFS. So it would this could potentially be one of the transport layers for Nebula. So it is a very cool technology, and you should definitely look into it and read about it and understand what it's doing and why.
Yeah, and we'll talk about this a little bit. Well, we'll talk about IPFS a lot, and we have talked about IPFS a lot in past sessions. And I'm in communication with the IPFS team to be at the Decentralized Web Games, or at least join us virtually. Because I think that IPFS offers opportunities to do some really cool networking in Hayden and other rural areas. So we might very well weave that into the Decentralized Web Games. But let me show you something that kind of highlights the dollars that are involved here.
You got to throw an ad blocker on there, man. Microblock origin.
I don't know. So the total market cap of the top 100 currencies, maybe it's more than that, is a little over $12 billion, of which, and this, I'm looking at coinmarketcap.com, but Bitcoin comprises 9.6 billion of that 12 billion. Ethereum's 1.1 billion. And by the way, Ethereum went from 0 to over $1 billion market cap in less than 12 months. So it went from white paper to about a $1.2 billion market cap in like 32 months.
Yeah. That's a lot of faith.
That's a great way to put it.
It's a lot of faith. And the guy that wrote the white paper, Vitalik Buterin, wrote the white paper when he's 19. So
so it's both impressive, but also not quite as impressive as it sounds, because that is impressive growth. However, the other thing you have to keep in mind are these are global numbers. So if you're looking at a company growing within a country, that's pretty damn impressive, but globally, slightly less so.
Yeah, well, I mean, so in the financial arena, $12 billion is nothing.
Yeah.
So
well, look at the F-35 project's over $1 trillion for just that one DoD project.
Yeah.
So
anyway,
it's a big number, but
this is that Steam toy that we were talking about. They've got a market cap of 78 billion, but I think they were up as high as like 250 million rather.
Wow.
What brought them back down? Yeah.
I don't really know. I don't follow it that closely, but they were well into the $100 to $150 million.
I don't see, is Dogecoin on there? I know that was.
Dogecoin is on.
Oh, it's still there. Okay. Now,
20
is that,
It's still around.
$24
yeah,
million.
that started as a joke and became an actual thing.
Yeah.
Yeah, well, here's one that I'm really interested in. Down here, Namecoin. This is like a DNS, a naming system. And Elio and I went to something called Decentralized Web Summit.
There it is, lower left.
Yeah,
It's in the recent tabs.
So
Yeah, this was really good. Actually, several Monero and Ripple and MadeSafeCoin, all of them had devs at this event.
yeah.
So
This was the Decentralized Web Summit on June the 8th and 9th at the Internet Archive in San Francisco. And it brought together about 300 of the people that invented the internet, and the other half were inventing what's next for the internet. So you had folks like Tim Berners-Lee, Brewster Kahle,
Van
Van Cerf,
Van Jacobson.
There's Van Jacobson,
Yeah.
all these luminaries, and then Juan Bennett from IPFS, he's the founder of IPFS. Trent McConaughey, who's with Big Chain BB, they just got funding this week, about £3 million pounds, and they are built on top of IPFS. But anyway, all these luminaries got together and we're talking about, okay, how do we take this centralized web and how do we get it back to a decentralized architecture? But this is a good segue into, well, let me stop there and ask you guys if you got any questions about that or anything coming up about that. So the Decentralized Web Summit.
Actually, real quick, because they made a big deal about this, and it is important. Does everyone understand? Because I thought I did, but I didn't. Does everyone understand the difference between centralized, distributed, and decentralized systems?
What is the difference between distributed and
So centralized, obviously, single server. That's what we run now.
Well, here,
And
I'll show you.
you got a diagram handy?
I got a diagram.
But yeah, there's a very fine but important distinction between distributed and decentralized.
Sorry. This got all kinds of press. So these are the three network architectures that Elio's talking about. This is centralized. This is basically what we're talking about when we're talking about Facebook or Google or whatever. Well,
Kind of between A and B, but yeah.
kind of between A and B, but the idea is that you get this centralized server that's problematic for a number of reasons. But if it's decentralized, then you've got kind of a centralized nodes talking to other centralized nodes, but they're not exactly centralized, but it's not as decentralized as a distributed network, which is completely peer-to-peer.
Yeah.
Like,
So the distinction I was making is between A and B. There's another kind of layer between there. So you have centralized systems, and maybe I'm mixing the wrong term there, but the other term, what was it? I thought it was distributed, but they're using that differently here. You have systems like Facebook and Google and all the largest websites out there that there's no server, there's no one computer you can buy that can serve the entire planet, nor would you want that because there's regional outages and the entire site goes down if it's fully centralized. So what they do is they have different data centers all over the world, all over the country, all over the world, and they're all part of the same system. They're all serving the same content. They're all owned by the same company. So they have a system that's redundant, but it's all owned by the same company. And the key difference between that, which you get some resiliency, versus a fully decentralized system that, like Freenet is a great example. That's my go-to. Freenet, BitTorrent's also not bad. Those are the older ones. Those systems are made up of any node. I can own a node. You can own a node. You can own a node. People in India or China or South America, literally anyone in the world might be operating one of the nodes. So in order to really destroy the system and totally impact, like bring it completely offline, either accidentally or maliciously, is almost impossible because the nodes can be owned by anyone, anywhere. And in order to shut it down, all of them have to be shut down. Versus Facebook, which has several different redundant data centers. But if they go out of business, those all shut down at the same time immediately. So there's a number of failure modes that a fully decentralized system doesn't have. And until no one or below a certain threshold of people stop caring, that system will. And a great example, actually the best, is Nutella. You guys remember Napster?
Yeah.
Remember LimeWire?
Oh, yeah.
So Napster was shut down because Napster, like Skype originally, was a decentralized system with a central coordinating set of servers. So when I wanted to contact you or get a file, I would talk to a central server and it would keep a directory of where everything was. And I'd say, I want this file. And it'd say, oh, well, he has it and he has it. You can go grab half from him and half from him. And then I would then connect directly and grab the files from you. It wouldn't go through the central server, but it needed that server to look up, kind of like how DNS lets you go to a website.
Like a DNS.
So all you got to do is shut down DNS and no one can effectively use the internet. And the same thing with Napster. All you got to do is shut down that main directory server. No one can use it because no one knows where anything is anymore. So Nutella took it a step farther and they said, we're going to use newer technologies, DHTs and such, to be able to index the entire network and find out where stuff is, but we won't need any one server to be operational. You'll be able to ask a whole bunch of different servers that anyone might own. So shutting down Nutella has been impossible, and people have tried. The music industry has been going after them. Last I heard, they were pouring in like $5 to tens of millions of dollars a year, just hiring companies to try to degrade service on the Nutella network to get people to stop sharing music. And as much as they've tried, they have failed. That Nutella is still operational. Actually, I haven't checked in quite a while, but last I looked, Nutella is still operational. So the robustness of a fully decentralized system is really nice because you'll never lose communication ability. It always works. But it's really for large adversaries that want to get rid of stuff. It's a real pain in the ass because you'll never get rid of, you have to go after every single node and just extinguish every single node, which is cost prohibitive, even for like a nation state actor. So
let's go back to screen sharing and talk a little bit about the decentralized web games. Does anybody have any questions or comments or anything?
So if you build something, let's say over IPFS, like do you use like, is there like a mainframe of IPFS and then you build your product over it, or do you like build your product first and then incorporate IPFS into it?
You want to answer that?
So IPFS is a protocol. So you would build, it's just like HTTP is a protocol, but then you need a server to actually move the bits. So IPFS, you run a local daemon, an IPFS daemon.
And there's one of those on here and here.
Can you pull up, you have one running on your machine?
Yeah.
Pull up and show them, because they have that cool globe visualization. You can see what's going on.
Oh yeah, I don't have that running. But yeah, this is actually IPFS on one of these Raspberry Pis. This is just basically their help, and this shows you all their different commands and stuff like that. But
so they have a visual interface. So you run the daemon, and the daemon then actually goes and just tries to find other IPFS nodes all over the world and connect to them and talk. And it has so the protocol tells it how to talk to other nodes. And it says, I have this data, and do you have this data? And they just talk, and they do kind of a gossip protocol. Might not be the fully technically accurate term, but they basically talk about where stuff is and what other nodes are available. And they maintain this mesh topology, like we saw the item C on there. So then when you want to build something, if you want to put data in there, you want to make an IPFS website essentially. You take the data, and there's local commands that you can point it at basically an entire static site structure. And they've done a great job of doing several levels, kind of like Git did, where they have the porcelain and the plumbing. So there's porcelain. I don't think they use this terminology, but I'm stealing it from Git because it's a good idea. Porcelain, like you go to the bathroom. Porcelain is the stuff that you as a normal person interact with. It's clean, it's shiny, it's easy to use. And then the plumbing is like all the pipes that, you know, you can build a bathroom, you can make it do different things. You could put in another sink or a second toilet or something if you're willing to get down and dirty with the plumbing. So Git has done that, where it has the porcelain commands for normal people, for normal use, and then the plumbing commands so you can do, you know, you build other tools on top of it if you want. And IPFS kind of has the same thing. So they've done a good job of putting porcelain commands on top, where you can take an entire website worth of content and you can just suck it in one go and say, put this in IPFS. And what that'll do is that will take all that entire hierarchy of data and it will construct a Merkle DAG. So it'll take the bottom layer, it'll do a depth first traversal, take the bottom layer of, you know, the files in each folder at the very bottom, checksum all those. And IPFS, they did a really smart thing. One of my favorite things about it is they allow multiple checksum algorithms. Git doesn't do that. Git, right now you are forced to use SHA-1. So if that's broken, Git's broken. But Git isn't about security. It's about version control. So anyway, IPFS said, look, we're going to let you use SHA-1 or SHA-256 or 512, or if they come up with new ones we don't even know about yet. They've built it future-proof, where you can use any algorithm you want. And they use something called multi-hash, so it can figure out which ones you're using. So it'll checksum all those. And then it will make a list of those checksums and make that directory object that has that list, checksum that, and it will construct this all the way up to the top. It gives you the master checksum that refers to that entire tree. And then it will insert that into your local node. Now, the way IPFS works, it doesn't, and this is a difference between Freenet and IPFS. Freenet is censorship resistant, like heavily censorship resistant. So as soon as you insert data, it doesn't store it locally. It starts spreading it around other nodes it's currently connected to. So it may not even actually land on your machine. It may immediately go to other machines because they're assuming someone's after you and is trying to shut you down. So that data's got to leave your machine and become redundantly available as quickly as possible. Whereas IPFS is for public data, benign data that no one's after you for. And so IPFS, it sits on your machine. Now, anyone who asks for a copy, whether they're across the world or across the table, then the daemon will do its job trying to locate that data and grab a copy. And once you grab a copy, now there's 2 copies of it. And so now there's twice as many places to get the data from. And as more people start downloading that data, it'll start effectively caching it all over the world. So the entire thing acts like a CDN. And the more people want the data, the easier and faster it is to get the data. The data kind of moves around the network. Whoever asks for it, it's right there. Like once they get it, that data is now there and it's locally available. So, and because it's all based on hashing, you don't have to worry about cache invalidation, because websites will do this. You know, big companies will cache stuff, but if they don't invalidate the cache, you'll get served. Like you go to the news page and you see
old stuff.
News from 3 days ago because the cache wasn't invalidated. And you're like, oh, that's not the news. I want to see what's going on now. So IPFS doesn't have that problem, because another smart thing it does, they've really thought about immutability versus you have to have mutability to, you know, to do stuff like news. So when you put something in, you get an immutable pointer to a, you know, a thing that can never change. If you change any bit of that data, it ruins all the checksums all the way up, which is good. That's what a Merkle DAG is supposed to do. But then how do you change your website? So IPFS said that's a problem. We need people to be able to have a website they can go to, but be able to make changes and keep it up to date as new things happen that they need to announce. So they have a thing on top of IPFS called IPNS, and you can create cryptographic keys and claim kind of your name and say, so this is my website associated with this identity that won't change. And then I can now repoint, you know, whatever static tree I'm pointing to. Now I just updated my site. It's a new static tree that's different, but I now repoint that thing to this new tree. So if you go by the NS, by the name system entry, it'll give you the new tree. So you'll always be seeing what's up to date. So really smart design, really important. That concept of mutable versus immutable and how they relate to each other is a really important concept. And I applaud the guys at IPFS. They've, you know, at Protocol Labs there, those guys, great job. They nailed it on that. So
yeah, so to kind of boil it down, why we're so excited about IPFS, you're talking about an alternative for DNS. This could be an alternative for DNS. You can build blockchains using IPFS. There's a database element, that big chain DB that just got 3 million pounds of funding. That's the database and blockchain element that's can be coupled with IPFS. The other cool thing is, and you might be interested in this, Bob, from the IoT, you can actually be disconnected from the network and IPFS will still run.
Yeah.
So these two Raspberry Pis can be fully functional with one another, even if the Wi-Fi goes off in here.
Yeah. So if
That's
they,
a big
if
deal.
they can still talk, so this is something from computer science. Whenever we want to sound smart, we always pull out CAP theorem, which is consistency, availability, and partition tolerance. And the last part of that is partition tolerance. If you cut the network, if you partition it into more than one network, what happens? And again, like we talked about earlier, blockchain technologies are totally partition intolerant. They cannot function. Their purpose is to have one unified truth. And when you have two different things sectioned off from each other, you can't talk to each other, so you can't maintain that unified truth, so it'll diverge and you got a problem. IPFS, because it's based on Merkle DAGs, not blockchains. And again, you could totally build a blockchain because the blockchain is just a constrained Merkle DAG. So you can represent blockchains, you can throw Git repositories, you can do a lot of cool stuff inside of IPFS because it's a generalized Merkle DAG transport. But yeah, it works totally. If you have a mesh network, if you have two things that can talk, like Jay said, they'll talk, they'll do their own thing. They'll be able to send data back and forth just like normal, but only to each other. Now, the interesting thing is when they get a connection to the greater internet, IPFS tries to heal the global system like really aggressively. So as soon as they have a connection to anything else, they'll be back part of a global network again. But if they get cut off, they'll still function. And anyway, so
there's also a huge security element associated with IPFS because it encrypts everything at rest. Yeah, I'm pretty sure it does.
Okay, I gotta read their paper again. It checksums everything, so you can't tamper with it without being caught.
Right.
The checksum.
But I'm pretty sure everything is encrypted at rest. I could be wrong about that.
Freenet does that. I don't remember if IPFS does. I don't think anyway.
But anyway, there's a huge security benefit around IPFS that I think addresses a lot of the cybersecurity issues that we're currently facing. So it's distributed, so you don't have a central server. It can operate with or without being connected to the internet, and the encryption adds a whole new level of cybersecurity. So anyway, those are some of the things why we're excited about IPFS. And we've invited, part of the team of IPFS has been in communication with me about the possibility of joining us at the Decentralized Web Games in Hayden. So with any luck at all, they'll be joining us one way or another, virtually or in person. And so let me go to the, let's talk a little bit about the Decentralized Web Games a little bit, if we could, unless you guys have any other questions about IPFS or anything else. Any questions?
So many, but I think we should probably keep moving.
So this is the Decentralized Web Games website, and this is still a work in progress. But the idea is that we will be able to have 2 days where we can try things in a real town setting and experiment with stuff that would be difficult to experiment with here, like drones, like mesh networking, like possibly robotics. I've thrown out some use cases that are just sort of designed to start the conversation. And I'm going to add some of those use cases and some of the feedback on the website. But the idea is to start to build a community so that we can take what was started in San Francisco in early June at the Decentralized Web Summit, that incredible gathering of people. And that was an amazing event to be at. But now the decentralized web games is designed so that we can actually take some of those ideas, some of those platforms, some of these protocols, and take them out in the field and actually try them and innovate and see what works, what doesn't work, what sort of problems do we encounter, and then do this like on a quarterly basis and start to scale it up among other small towns so that simultaneously this is happening in 2, 3, however many locations we want to experiment. So let me stop and ask you guys if you got any questions about that.
I'm still having a little trouble wrapping my brain around it. So let me present to you what I heard, and you can correct me where I went off. So the decentralized web games is an opportunity for us in the community to kind of get together and do like hands-on experimentation, kind of like a hackathon, but we're bringing it, but it's not limited to just computers. We can bring it to tangible real world stuff.
Yep.
Okay.
Yeah, you should have seen the initial list of technologies to investigate. I'm like, we got to boil this down to 3. That's like 30 something is way too much.
Yeah.
So, so we kind of narrowed it down to the ones that people seem to show the most interest in, that also seem to be the most likely, that like lowest overhead to get up and running, like doesn't cost us thousands of dollars to set up a test bed, and something we can deploy quickly.
Yeah.
So, but yeah, the long-term plan is to get a whole list of 3 dozen technologies, like cutting edge stuff. It's a lot of stuff.
there's a lot of different directions we can go with this, including setting up a cryptocurrency for a town.
Oh, that would be cool.
Wouldn't that be cool?
Yeah, that would be.
So, Hayden dollars, basically. Winkleman dollars, Superior dollars. And, there's about literally 30 different directions we can go with this. But right now let's play with drones, let's do some mesh networking, and let's lay on top of that prediction markets. I personally really want to experiment with prediction markets. So let me show you if you go to the events tab, and you go to this, I did a little video, 2-minute video. You can watch that at your leisure, but there are some similar events that have happened primarily in Europe. So this electromagnetic field, 2016, this just happened in August 5th through the 7th in the UK. But this is actually an event where and I think they might be up to like 1,000 participants or so, maybe 1,500 participants. They go off into this remote area of the countryside, and they set up tents and campsites. Here's a campsite, and they just have workshops. And they do things like they have talks on satellite systems, Iridium, AMSAT, cryptography, robotics, all kinds of stuff. So this concept of the decentralized web games, the idea of a community kind of gathering and building their own city, if you will, and having this interactive sessions has already been pioneered. So in addition to the electromagnetic field games, or camp, there's also the Chaos Communications Camp, which is held like every other year. So one year it's the electromagnetic field event, and the other year it's the Chaos Communication Camp. And in this, and this is actually, looks like it's even bigger, but they had some really innovative talks and workshops and hands-on stuff as well.
That's the same group though. That's the Chaos Communication Club.
Yeah.
Yeah, these are some of the original hackers. They've been around since before the internet, or like right with the very early internet. So this is probably why it's that large. This is one of the better known groups that's been around from the beginning.
Yeah.
So
The idea is to basically, that's their camp at night. The idea is to go into Hayden or Winkleman or both, and here's basically what I presented to the town council. To boil it down is to build community, to have education and hands-on demonstrations and games, and to do innovation and collaboration. We're focusing on cybersecurity and kinetic security communications and the Internet of Things.
Where
This-
is this? How
Um,
far away is?
2 hours away. Isn't it?
yeah, it's about 2 hours away. It's a little less than 2 hours
it's like
away.
an hour and a half from here, I think.
Closer to
You
Tucson.
go out to
It's
Superior.
midway between Phoenix and Tucson.
Yeah, you go out to Superior, and then you had another like 33
I
miles.
thought
south.
Hayden was straight west on Highway 60.
East.
It's east.
East, I'm sorry.
Yeah.
East.
Yeah,
Yeah,
so
well,
let's
it's
take
not
a,
quite straight. You go to Superior, and then you duck down to Hayden.
Okay.
So
let's
it's
take a
about
look at
30, like I said, I think 33 miles or so southeast of Superior.
Let's see where that is. So
So, it's on the 60.
Let's take a look
Superior's
at that.
straight on the 60 toward like Globe and Miami and all that. And Hayden is the right turn down the 177. It's where the biggest Sarco mine is. It's a huge open pit mine. It's actually beautiful. You come around one little turn and you just see this massive hole where they've taken out an entire like half of a mountain. And it's copper ore, so all the dirt is almost like the painted desert up in northeastern Arizona. It's all multicolored and it's pretty awesome.
Yeah, it's really, I love the place actually. So Hayden, Arizona. So that's kind of a picture of,
Hit directions there. Oh, so if you want to show people
Yeah.
how far away it is.
so the town
town.
has 662 people. Elevation's about 2,000 feet. There's kind of a picture of the town. This is the police. This is kind of like the downtown street, and we can use like part of the street. There's the smelter. Let's see what else we got here.
Yeah, that smokestack's massive.
Yeah, this is the fire department. That's the smelter in the background. This park, like right here, the majority of our activities will probably be in this park.
Yeah, it's an hour and a half from here.
Yeah, but let's take a look at exactly where it's at. So here's Phoenix, here's Tucson. So there's Tucson, Hayden, and Phoenix. Basically, you go out 60 to Superior and then head down to 177 to get to Hayden. And it's about an equal distance for people coming from Tucson and Phoenix.
Smack dab in the middle.
Smack dab in
Yeah.
the middle. Let's go to Google Earth.
Yeah, it's really not that bad to get to from here. So
So let's see, where are we here? Okay, so here's Hayden, and if we zoom in on this,
I forgot that Aravipa was out there too.
yeah, it's beautiful. So let me show you some cool points about this. The Gila River is running right through here. What is this? So there's the mine. But this is the Gila River, which is running, I think, year round. There's a big park right here, which we might be using. This is like a vacant park. This is where the rodeo grounds are at. This is the golf course over here. And we could probably use the golf course. At a minimum, I think we'll be using the, let's see. So here's the swimming pool and the library. This is the park that I just showed you, and this is that downtown area. But we can also, at a minimum, use this. There's a park here at the golf course, and then there's another big park over here that would allow us to, camp and do whatever.
October 27th to 28th.
Yeah.
Coming right up.
There's a high school. So there's a bunch of things that I think this offers, some capabilities that are very conducive to experimentation and innovation. So do you guys have any questions about any of that?
So it starts at 9 o'clock on the 27th. What do? We show up with a laptop and do what then?
Well, you certainly bring your laptop, but I'm going to put a schedule up on the website with like slots, like 30-minute slots. And the idea will be every 30 minutes we'll be starting a different event or a game.
Okay.
Like, drone races or drone hide and seek events. That's yet to be.
So that's still being developed.
Yeah, that's still.
Okay. And then when we sign up, there were like 4 different options.
Right.
Which one did we pick?
Well, at this point, you should pick the participant,
Okay.
which is $75.
Okay.
Okay. If you want to basically be able to fully participate in everything else. There is a free version called an assistant. But what I'm planning to do is say you can attend both days, but one of those days you're going to be assisting around the event, doing something. Does that make sense?
Yep.
And then the other ones are the core contributors for $15. And let me pull these up while I'm talking about it. So if you click on this, click to participate, and then go to the tickets. So this assistant, basically, there'll be maybe, 20 or 30 of these assistant or assisting tickets for people to say, I want to attend for free. Okay, well then one of those 2 days will be asking you to do something, man parking or don't know just yet.
Okay.
The core contributors for $15, basically, you will be getting communications about how this develops. You can submit ideas for the events, and there will be some probably some online conference calls and things like that you can join. The collaboration contributor for $25, those people will be able to actually be on Google Hangouts the day of the event and ask questions and have more of an interactive role. The participants for $75 will be able to be at the event, participate in the games, basically do everything that you would want to do at the event. The celebration contributor for $125 will have an end of the event party, and it'll either be on Friday night, maybe Saturday night if you want to make it like a Halloween party, haven't quite decided. But that will be basically where people that haven't attended the event can attend and basically chat with the people that were participating, were involved in the games and so forth. And if somebody wants to basically sponsor somebody at this celebration party in the then they can pay $125 and designate maybe somebody local to attend. So then the last area is just core patron. If somebody just wants to make a donation or craft some sort of sponsorship package, they can do that. So I'm trying to build this so that this is like a crowdfunding, only we're not using Kickstarter. And this is truly decentralized. It's not like, we're asking Google or Facebook or whatever to be the sponsor of it.
Yeah, that raised some eyebrows at the Decentralized Web Summit. They had large sponsors, and so they were charging, I think it was like $75, about the same for tickets.
$75, yeah. Same price.
But they had people the tickets were covered for them by like Ford Foundation and such, and that's fine. But they had like Google is on there, and Google has been very anti-decentralized. They've been trying to centralize everything because it helps their advertising model. So people are like, wait, this is what? It's decentralized, but Google's funding it? They're like, wait. So yeah, there were a few companies there that were part of the funding. So that Jay has addressed that for this.
Yeah.
We have no large corporate sponsors right now that cast any doubt about the motives.
And I'm going to be making some another tab on the website talking about the funding, how it's going to work, where the money's going to go. But part of the money's going to go back to the community. So after we cover like the bare basic minimum for insurance and sanitation services and security and stuff like that, everything that is above and beyond that, 25% of that is going to go back to the community in some form or fashion.
How many attendees?
Trying to limit it to like 150 attendees. So probably about 70 will be by invitation, like the IPFS team, the Big Chain DB team, people that attended the Decentralized Web Summit in San Francisco. Then probably another 55 or 60 that are the participants, where there's just going to be like 5 at a time available on those. And then 15 students, local students, will be invited to be part of it. So that's pretty much the composition of the group. Does that make sense? Any questions about that?
No, that makes sense. Seems interesting. What if you can only make one day, like the 28th? Is there?
We're gonna have to be a little flexible on that. Like, let's say this thing only raises like $500 or whatever. Then we'll probably have to scale it down to one day. As Elio keeps reminding me, time is running short. It's running short.
So Jay has pitched this a few times, and the response has always been, that's an amazing idea. It sounds like a great event. When is it? And when he's like, oh, it's October, everyone's like, you're effing insane. It'll take 3 times that long to plan that event and get everything together. So that's been that's really been the only objection I've heard, is that this is a very ambitious time frame. So we will see how it comes together. And I'm a little too busy to help actually plan this much. So I'm being as supportive as I can. This is Jay's show.
Well, you are. You've helped a lot.
So
Elio went to the town council meeting with me when we pitched the original idea, and he also went back and did a kind of a scouting of the town and so forth. So, and Elio's got some great ideas on doing some networking and improving the internet service.
I kind of feel a little bad, but not really. So I do a lot of cybersecurity stuff locally, and I've helped schedule like Code Day and a whole bunch of other hackathons. And we got some big plans for different events. I just did 3 panels at AZ SciTech. So there's a lot of stuff going on. So like, this is what I do, but because of the time frame, I've only been able to help Jay like this much, when normally I would be doing at least half the work with him. But one of the things that we mentioned that got a lot of good feedback, again, that initial massive list of technologies, I kind of slipped in there mesh networking, because any of these technologies that we're talking about, IPFS, all these other things, they're cute and they're interesting, but if you're running them over today's internet as an overlay, you're only getting a small part of the benefit. And that's part of the problem we have right now with the internet, was, if you look at the history, first we invented the telegraph, and then we figured out how to modulate and have the telephone, so it wasn't just on and off, it could make sound. And that was cool, but it was all circuit switched. And then the next big revolution in human telecommunication was packet switched with ARPANET, which later became the internet. And that was a huge advance, the idea of cutting things into packets and letting them just flow over this decentralized mesh and reassemble at the other end. And the military needed that, and society would benefit greatly from having that ability to have, multipath resiliency. The problem is, as it started getting rolled out to the public, the telcos took it over. And telephone companies are used to circuit switched because they've had, ever since the telegraph was invented, they've been putting circuits out there. So today we have this weird, kind of crappy hybrid where you have the internet. Anyone have more than one internet connection at home and know your cell phone doesn't count? Anyone?
No.
So there's a single, it's not multiply connected. We have a distributed star topology in almost all cases. I've known a handful of people who actually pay for 2 separate internet connections. So if their internet goes down, they got nothing. I mean, now you can kind of fall back on the cell phone.
Mhm.
But for the most part, if Cox goes down or Quest goes down, and those are generally your only choices, you got no internet. You got to go somewhere else. So we have this amazingly robust technology called packet switch networking that has been deployed over a circuit switch topology. And so we're not really getting the, multiplex is easier, and you can get QoS, which is nice. But that's about it. All the other advantages a packet switch should give us, which are, with regards to resiliency and redundancy and, failure resistance, all this kind of stuff, we get none of those. So the fix to that is mesh networking, wireless mesh networking. And we've seen that in other countries. We've seen that in New York. One of the most prominent examples in the US was the Red Hook Initiative when Hurricane Sandy just decimated New York. Certain areas were completely, no service. These guys jumped in and they set up a wireless mesh. They were using, I think it was Linksys. Was it open? I don't remember which software exactly at the moment, but they had these off-the-shelf routers that they had flashed with this mesh firmware. And suddenly they deployed them all over the city on battery. And even though it took the telcos like 2 weeks, 3 weeks to restore service, these guys had IP connectivity where you could email friends and family and let them know you're okay. In less than 24 hours, it was back up and running. And it wasn't at full capacity, but it was good enough to send a short email and say, hey, I'm fine. House has some damage, but I'm okay, which is really important. So we need that. We need that level of resiliency. And for the third revolution in human communication, which IPFS is one of the examples. Like I said, there were prior technologies already out there for a few decades. In order to fully realize that, we need an entire stack. That old OSI model where you have the wires down here or the radio waves, you have the physical layer, you have the link layer, you have all the way up to the top. You have to have a whole stack that can do those things. And right now, all these things are sitting up here on top of the old stack. And they're using all these old technologies that are failure prone. So wireless mesh fits down at the bottom like layer 2. And it now allows us to finally truly have a physically multiply linked network so that if my device is connecting to your device, to basically everyone in the building because it's in range, I now have 20, 30 connections that are redundant. So if your device dies, it doesn't affect me. I've lost 1 out of 30 connections. I've just dropped my bandwidth by 1/30th, which is not really a big issue. So this is the technology we want to play with and prove out.
The biggest interest by far has been in the mesh networking. So the people that I've talked with said, I want to play with the mesh networking. And, I think that's awesome. And we'll see how how the community comes together and what they want to put together for the mesh networking. Mesh networking isn't very interesting to watch.
No.
So
Technically, it's really cool, but technically,
technically it's really cool, but it's not very interesting to watch.
You're right.
So if we have the drone games with the mesh networking with the prediction markets, those are the 3 elements that I want to focus on. Out of it.
And you can combine them. You can do interesting stuff. Like
stick a router on a drone and have it fly.
Yep, you can.
So you can do a drone like automated war driving to map out the network and do really crazy stuff like that. That gets interesting.
Well, and the other thing that we didn't really talk about with IPFS, but IPFS, because it encrypts video, you have a verifiable copy of a video that can't, well,
I know. I'm sorry. I'm sorry. Fixating on the use of encryption because I don't think it does it. You know, as far as I remember,
it might not do it on the fly,
bring
but
your own encryption. What it does, it checksums. It cryptographically checksums, which gives
Okay.
you what you're talking about.
so the use
So-
case, we are seeing almost on a daily basis now where video becomes a central
Yeah.
part of our
Yeah.
critical events.
Well, this goes to a larger issue in courts of chain of custody,
Right.
proving the validity of evidence to be used in court. And Merkle-Daggs, any Merkle-Dagg system gives you, because it's cryptographically checksumming in layers, it gives you that ability to have chain of custody built into the system.
So the
So-
swimmers, to bring it back to a real life use cases, the swimmers down in Brazil that got into the scandal about the, whatever happened at that convenience store or gas station or whatever it is, was that the real video?
Yeah.
Had the video been tampered? Part of what we can experiment with is some real life scenarios where drones or fixed cameras or whatever can be taking in this video of a scene, and it can be verified that this is the video that's taken, and different people can check using IPFS.
And this
so day in, day out, we're seeing video be captured, and that video becomes a critical piece of security of what happened.
And
those are some of the things that we can experiment with at these decentralized web.
this is one of those areas that's interesting because the benefits go both ways. So from talking to special agents, some of the stuff I do, this is good for the public because now that video from the cops is legit and has not been tampered with. So it's good for the public to prove their innocence for public trust. But it's also really good for the FBI and police and other investigative agencies because they spend right now a tremendous amount of time. They have personnel that have to prove chain of custody. If they get a video and they want to use that in court, it's a tremendous amount of effort and work to prove that they pulled the video off, they didn't mess with the video, and like all these little I's are dotted and T's are crossed so that when they bring it in front of a jury, it won't get thrown out. And if they screw up one thing, even a tiny bit, or not even screw it up, just they can't convince the jury that it's legit, it gets tossed. And they've wasted all that manpower to, risking their lives to obtain the video, if they're, confiscated it from somewhere, if it's an illicit video of something. So there's a lot of time, money, and manpower that's wasted on chain of custody right now. So providing that in the system frees them up to do actual investigation and useful work. So they don't have to waste their time establishing chain of custody. It's now a property of the system. So the feds and the cops are super excited about this because it makes their life easier and it makes the civilian's life better. It's one of those rare technologies that everyone benefits equally from it.
And when you've got the network architecture that we were talking about, where you don't have this central server that could be tampered with, you've got all these peers that are talking with one another, that just adds to the robustness as well as the provability that this is the actual video that happened.
Totally flips the economics of like hacking. If you have a website and I don't like what you have on your website and I want to get rid of it, right now it's relatively easy, even with relatively meager hardware. I mean, not a phone, but with a laptop or two, I can DOS your website and take you down. I can use a reflected attack and generate huge amounts of traffic and just take you completely offline. That's really annoying. Whereas with the decentralized system, the more popular data is, the more sources there are. So it scales. The more people want to see it, the more work I have to do to try to destroy it, which is really, really hard to do. So an attacker now has to spend a tremendous amount of their time and effort just to try to take something offline and probably still fail at it. And it's still available to anyone who wants it at a slightly degraded, speed. Versus today where it's trivial to just knock a site offline. Like Brian Krebs, I don't know if you saw that. Brand new ingenious attack. I think it was on, his website. Well, is it back up? Krebs on security. He just got hit with a greater than 1 terabit per second flood of traffic. Terabit per second. Google barely moves data at those rates, and his website got slammed with that much. They had to just shut his site completely down just because it was affecting other customers. The major internet companies that were he was serving his stuff through were having impacted service because of the attack against him.
So we're almost at 8:30, which is kind of our cutoff time, but and we covered a tremendous amount of ground tonight. And I hope this has been interesting for you guys. But do you have any comments or suggestions for the decentralized web games, or any future events? Did this cover what you were hoping to cover, or?
Yeah, definitely. I mean, I'll definitely watch the video. There's a lot of terms I should have brought a notebook. Yeah, I mean, I definitely want to look into a lot of things, like do a lot more research on it. So thank you. It was really informative, and looking forward to the decentralized web games. That sounds really interesting. So
Cool. Bob, you have any comments?
No, I'm just curious how late at night that thing's going to go. You're talking about 9 a.m. to 9 p.m. the next day. I mean, you're going to have
No. We're going to cut it off at 9 p.m. every night.
Oh.
So on Thursday night we'll cut it off at 9 p.m. and on Friday night we'll cut it off at 9 p.m.
I just had the impression it's going to be a 24-hour.
No, we're not doing the code day hackathon thing.
No, it's not a hackathon thing. But I'm glad you brought that up, because I'll make that clear. I mean, the idea is, we'll have some time at night to experiment with whatever would be cool to experiment with at night.
Yeah.
And then and none of this is cast in stone either. So, but after 9 p.m., the idea is we cut off all the games or activities and whatever, and then it's just kind of like social time. Okay. And if you want to go to a different town and stay in a motel, that's fine. If you want to camp out, that's fine. If you want to bring a motor home, that's fine. So, but one thing I do want to make clear is the October event, even though it's coming up quickly, that's going to be kind of like it's almost going to be like a prototype. But the idea is to have this every quarter. So at the end of January, we'll have a better base of experience and knowledge and community, and we can do it again at the end of January.
is this the first one?
This is the first one.
Wow. Okay.
So,
Yeah, this was inspired by the Decentralized Web Summit, and the idea was to broaden it out to not just web, but all manner of decentralized technologies, web, physical, anything. And actually came out of, so another thing we're trying to do longer term, probably January, February timeframe, is hopefully hold the second Decentralized Web Summit in the state here. And that's going to be basically a clone of the first, but we're going to bring some new elements to it with regard to cybersecurity and IoT. So this came out of those planning meetings and kind of split off into its own thing to accommodate the wider scope. So.
all right.
Okay.
You guys have any other comments or questions?
I was just kind of wondering, because we were just to kind of call back to the video and the encryption thing. Best technology that was doing that?
Yeah, look into that. What Jay's talking about is cryptographic checksumming, I believe. I could be wrong. The last I checked, IPFS is bring your own encryption. It cryptographically checksums, so like an SHA-1 or other, and that allows you, if anyone changes even a bit, you can recalculate the checksum and find out that they're not the same. Yeah. They have that wonderful avalanche property, so one bit causes a total change. It's not off by a digit. The whole checksum, the whole signature changes drastically. Okay. So, and because you're checksumming everything all the way up, that causes all the rest of them to change drastically, and the whole tree is invalidated.
So how far away are we from a practical standpoint? Because we're looking at blockchain and how, so the banks and everybody kind of jumped in on that. And you mentioned it has some fundamental technological flaws that they're there. Everybody knows they're there, and people jumped in.
Yeah.
So and so we understand that that's about 7 years old, blockchain, from
some of the research goes back farther, but yeah.
Correct.
And I don't know if I'd call them, I guess I would tend toward flaws, but you could call them limitations of the technology.
Sure.
I think the future, I think the blockchain is going to be a chapter in the advancement of these technologies. But I think personally that Merkle DAGs, just unconstrained Merkle DAGs, are far more interesting. And they allow, so Jay and I have had extensive discussions, just the two of us, about the nature of money. And we haven't finished these. We're still early in the process. We've been bouncing ideas back and forth. But money, this is from me, so he can add in his piece after. Money is a way of doing in-way trades. If I want a nice shirt and you have that, but I don't have anything you want, but he has something you want, and I have something else, we can do this in-way trade where I give him something and he gives you something.
I'm going to interrupt you.
Yeah. Okay.
I'm going to cut off the
anyway,
hang
so
out in a minute. You guys can hang out.
oh, okay.
and
Oh, sorry about
chat.
that.
Gotcha, gotcha.
But so to get back to your question, Glenn, yes, we're basically in about a 7-year history here for the blockchain. And what other questions did you have?
Well, so what I was trying to figure out, like all the stuff you mentioned tonight, the video piece, I can see that as, very useful in this distributed PIPFS. I can see how it's used. But what I'm trying to wrap my brain around, and hopefully the other folks who are there online, is how far away is this from actually using it somewhere? Because the blockchain right now is
fine using. I mean, they have in some places they have ATMs, and there are companies accepting Bitcoin
right
for the last 2-3 years at least.
Yeah.
So
You can go into Tempe. There's ATMs for Bitcoin.
And what was the card that Christian had? There's like a credit card that you can load up with Bitcoin, and you swipe it like any Visa, and you buy things. And he was paying for stuff on our trip with Bitcoin using that card.
Yeah.
So if you're just
It's usable.
it's usable now.
But it's much like the internet was in like 1995. It's usable, but there's a lot of human-friendly elements that could be put into place so that it's more practical.
Yeah.
So does that make sense?
It's usable, but it's not ubiquitous yet.
Yeah.
It's still
okay.
an unknown number of years from being the main way people send money. And it's also
so I'm going to cut off.
In
I'm going
Paysa,
to cut off the
which is a
Google Hangout,
technology,
and
but
thank you for tuning in. I hope this was
without some
interesting.
advantages.
Please, we'll have another session on October the 26th, a monthly session. You can see the contact information under the contact page on Desert Blockchain. Feel free to contact me, submit questions, comments, whatever you might have, and check out the Decentralized Web Games site. It's going to be have more and more stuff on it, and consider signing up to participate under the click to participate. Thanks. Have a good night.